Hi, you're watching Floyd Steinberg's YouTube channel. Last week I talked about the Yamaha MU15, and to my surprise many of you were quite intrigued to see these old extended general MIDI boxes are quite capable of synthesizing sounds. So I came up with my own MIDI controller that enables you to use all the hidden parameters on those XG devices. And if you think that's interesting, you're wrong. This is going to be an excruciatingly long tech talk. But don't worry, together we'll survive it. Here we go. The idea here is to build a single-page web app that lets you edit all the hidden parameters of Yamaha's XG standard. On most devices, you can change a handful of parameters like filter cutoff frequency and attack and release, but you can't edit LFO or reverb parameters, for example. By the way, this screen was sent to me by today's sponsors, Elro. This is a 1280 by 400 pixel IPS touchscreen that registers as a USB mouse. It's solidly built, sharp and bright, can mount a Raspberry Pi on its back or can be mounted on a tripod. And it's the perfect fit for DIY projects, and I'll certainly find a good use for it on this channel. Please take a look at the webpage, as they have plenty of different panels in all sizes, resolutions and price ranges. And look, they recently celebrated their 10th birthday. Hooray! Single-page web app means this is one HTML file you can load into your browser, and all the designs, UI elements and scripts are there in one file. There's nothing else that needs to be loaded. WebMIDI has been around for some years now, and with the exception of Safari, all the major browsers support it. Okay. So here I am in Visual Studio Code, and I've installed an HTML preview plugin so I can see my work in real time. By the way, this won't be an in-depth tutorial. I'll just rush through the concepts and the main functions, and if you're interested how all of this works in detail, you can download the source code and take a look at my annotations. My idea here is to create a form that is divided into multiple field sets. Each field set contains a group of range sliders that belong to a certain set of related parameters. First, I'll create some select boxes for the MIDI input and output devices connected to the computer. Now, let's format these elements. It's always a good idea to define a set of colors so you can change them easily later. I've arranged my input sliders as a list, so let's format that accordingly. Add some color gradients to the field sets to make them look more distinct. Now let's do some copy and paste coding. Head over to MDN and look up WebMIDI. Copy all the example scripts there into a script tag at the very bottom of the page. Let's quickly load the page into a browser, and we can see it's asking for MIDI permission now. Right, now let's add our MIDI devices to the select menu. Again, copy the example code from MDN and modify it so it doesn't print them to the console but creates options in our select boxes. The options will display the name of the MIDI interface and contain their ID as a value. This function is triggered on MIDI success shortly after loading the document into the browser and you confirming that it's allowed to use the MIDI function. Let's add a new field set now. This will contain two range sliders for changing filter cutoff frequency and resonance. The range slider can have a value and the maximum value, which will be 127 according to the MIDI standard. I'll also name all my sliders CC_CC number, which will come in handy later. Now let's add some style information to make the slider stand vertically and touch-friendly. Next, I'll add an event handler to all sliders. The event handler will be attached on MIDI success at the start of the program and will listen to slider movements. Due to my naming convention, it's easy to determine the kind of MIDI command and its number by looking up the slider's name. For example, the first slider for cutoff frequency is named CC_74, so my script knows it's the CC command and its number is 74. Now all we need to do is to send the cc value to our synthesizer. So once again, copy and paste the node send command from the MDN page to our script, but we'll need to tweak it a bit. We need to add the MIDI port ID, cc number and value as parameters, and then change the message number from hexadecimal 90 to B0. Now replace the console log command with that command. Also, add some lines that determine the active MIDI port and the cc number and value, and then replace the console log command with the MIDI send command. And now we have a working filter control. Nice! Now we can easily add more cc sliders. Luckily, I found this webpage which has all the information needed. I encountered a small roadblock when working on the amp envelope controls. Attack and release have their own cc numbers, but decay is handled by so-called NRPNs or non-registered parameter numbers. These allowed companies in the past to include controls outside of the XG standard if they wanted to. This works by sending 3 consecutive cc commands, the so-called most significant bit or MSB on cc99 first, and then the so-called least significant bit or LSB on cc98 next. And after that, you send the actual value on cc6. Let's take a look at how this works on the decay time example. The documentation tells us the MSB is 1 and the LSB is 64 here. The possible values range from 0 to 127. Now I'll add a new slider with a range of 0 to 127 and name it nprn_decay. In my code, I can now set up a switch that reacts to the nprn names I specified and then create an array containing the MSB and the LSB 1 and 64. I then need to issue 3 consecutive cc commands, cc99 with a value of 1, cc98 with a value of 64 and cc6 with a value specified by the user operating the slider. Nice! Lastly, let's take a look at how to handle sisx commands. These are mostly used for setting up the effects. A sisx command is a couple of bytes you transfer to your synth. It always begins with a hexadecimal F0 and always ends with a hexadecimal F7. The second byte is always the vendor ID, in this case 43 for Yamaha. Here you can see that we can set up our reverb algorithm using the 7th and the 8th byte in a sisx command. The 7th byte specifies what we're changing and the 8th byte specifies its value. Knowing that, we can add some more range sliders to our app. As I'm lazy, I'll name each slider exactly like the sisx command it's going to issue, and then I'll just search for the XX string and replace it with the slider value. Then just split the name into an array and send it to the synth. And that's all we need to know to finish the editor. In the time I had for making this video, I managed to create this editor for reverb parameters. All that's left to do is to make sure the document doesn't move when operating the sliders, which is easily done with some CSS instructions. And here it is, my yet unfinished but functional web MIDI based touchscreen operated MIDI controller for XG devices. I've put this onto GitHub, and if you feel so inclined, please add more functionality to it. Yeah, and that's it for today. A web MIDI-based controller for your old XG or GM synthesizers. And if you think this was a good YouTube video, you might have a problem and should get that checked. But anyway, please do the YouTube thing. As always, thanks for watching. And see you again very, very soon. Bye bye.